Okay, so characteristics of quadratics. So we've got that on the front, and then you're going to open it up. I'm going to fold it back in half just because I don't have enough room on my page, but we're going to be writing across both pieces. Okay? So I'm folding in half just because I don't have enough space to write everything. And let's do a little bit of review. Let's talk about what we already know about quadratics. So what we already know about quadratics. What we already know about quadratics. We know that in order for it to be even called a quadratic, what is the number one thing we look for to confirm yes or no? I guess confirm is yes. That this is a quadratic. What do we look for? Exponent of 2. The exponent must be 2. If it's an exponent of 3, nope. If there's no exponent, nope. Must be an exponent of 2. We know that a cannot equal 0. And what is a? What does a represent? Sam? The coefficient of x squared. Because if a is 0, if the coefficient of x squared is 0, guess what? There's no x squared, correct? Making it not quadratic. We know that if a is positive, what? It opens up. We know that ones that open up, right? Quadratics that open up. We know that quadratics open up have a maximum or a minimum. Do you know what the top is if it opens up? No, you don't know what the top is. So it can't have a maximum. It has a minimum. Which is the bottom of the graph, right? Yep. Let's keep going with that. We know that if a is negative, what? If a is negative, what do we know? It what? It opens down. We know if it opens down, what do we know? It has a what? Maximum. It has a top. And I guess before we started talking about all of this, opening up, opening down, we should have given it a name. What opens up or what opens down? What's the shape called? The graph is called a parabola. The graph is called a parabola. I mean, so we know quite a bit about quadratics already. We know that it has to have an exponent of 2. We know that a cannot be 0. We know that if a is positive, it opens up. We know if a is opening, if it's opening up, it has a minimum. We know if it's negative, it opens down. If a is negative, it opens down. We know that if it opens down, it has a maximum. And we know that the graph of this whole thing, all of these things that we're talking about, is called a parabola. We also know about standard form. What is standard form? perfect. Or maybe it doesn't say y equals, maybe it says f of x. Remember, that's called function notation. Or it could also be 0 equals. Sound good? Those are all the things we already know about quadratics. Oh no. I found it. Okay, so we talked yesterday a little bit about when we graphed these parabolas. What shape is a parabola?
An arc.
It's an arc. It's a U, right?
Uh-huh.
It's symmetrical. What does symmetrical mean?
It has a line of symmetry.
What does a line of symmetry mean?
Both sides are the same.
It's both sides are the same.
Both sides are the same. So if I folded it in half, the left side and the right side would line up.
Yeah, they match.
That's called, in a parabola, right, in a graph, that's called an axis. Like the y-axis and the x-axis, those are lines on a graph. It's called an axis of symmetry. It's called an axis of symmetry. The axis of symmetry in a parabola is where you could fold it in half and it would line up perfectly on both sides. Ladies and gentlemen, if you folded a parabola in half, which way does the line, the folding, the axis of symmetry, which type of line is that fold? Which type of line is that fold? Chris?
The y-axis.
It could be the y-axis, but it could also, the graph could be over here, right? It may not be on the y-axis. What type of line is it? It's a vertical line, right? So the axis of symmetry in a parabola is vertical. For those of you that struggle, it's up and down. Now think back to linear equations. A vertical line has a specific equation. Every vertical line starts the same way. Just like every diagonal line is y equals mx plus b. And just like every quadratic is ax squared plus bx plus c. Every vertical line has the same formula. Every vertical line, even though it's vertical and the y-axis is vertical, every line that is vertical is an x equals. X equals 4 is a vertical line at 4. Because you go over to 4 and draw a line. If it was y equals 4, you'd go up to 4 and draw a horizontal line. But this is a vertical line, so it's x equals, and here's the formula. To figure out your axis of symmetry, negative b, meaning the opposite of the b value, divided by 2 times a. Negative b times 2a is the axis of symmetry. The axis of symmetry is negative b over 2a. So this is actually going to help us graph. Because doing negative b over 2a gives us an x value that we can then substitute into our problem. It tells me where to start my graph. The axis of symmetry, it's a vertical line, hint, hint, up and down. The formula is negative b over 2a. Whatever the value of negative b divided by 2 times a, whatever that answer is, that's where we draw our vertical line of symmetry. That's where we could fold our graph in half. The definition is the line, ooh, that's not how you spell line. The line that divides a parabola into 2 equal parts. The line that divides a parabola into 2 equal parts. We draw a line vertically. You could make it dotted if that helps you, right? Like a little tick mark line going down to show you that it's the axis of symmetry.
Yeah.
All right, so can you find the AOS, axis of symmetry, for 3x squared plus 10 equals 6x? Can you find the axis of symmetry for 3x squared plus 10 equals 6x? What's your b value? Ooh, what's your b value? Why is your b value negative 6x? It's a 6x up there.
Because you have to subtract it from the right side.
You have to first convert it to standard form, right? 3x squared minus 6x plus 10 equals 0. Yeah? Don't forget to do that. And so negative b, or the opposite of b, what's the opposite of b? The b value is negative 6, so that's like saying negative 6, correct? Which is positive, over 2 times, what's your a value? 3. What's 6 divided by 2 times 3 is 6. So your axis of symmetry is at 1. Axis of symmetry. All right, I'm turning the page to the other side of this, right? So now let's talk about another thing that we can now use that we know about the middle of our graph, the axis of symmetry. We now can use the axis of symmetry to find something called the vertex.
That's kind of cool.
Lots of things have a vertex, or the plural, vertices, right?
Superhero.
Like a square has 4 vertices, and a triangle has 3 vertices. An angle, a right angle, has 1 vertex. What's a vertex? A corner, or what we really want to call is a turning point, right? Because is there a corner in a parabola? No, but does it change directions at one point? So a vertex is a turning point. A change in direction. In a parabola, it's an ordered pair. In a parabola, it's an ordered pair. And what's the general formula for an ordered pair? Every ordered pair is in what? XY. X, comma, Y. Ladies and gentlemen, X, comma, Y. You have to have an X value. You have to have an X value in order to have an ordered pair, don't you?
Mm-hmm.
Where do you think the vertex of a parabola exists?
At the apex?
At the apex,
Ooh,
at the maximum, or at the minimum. Is it on the axis of symmetry?
Yeah. Should be.
Right? I mean, like if you're folding it in half, shouldn't the vertex be right in the middle of that fold?
The pointy bit.
The pointy part, right? The change in direction. Do we already know the X value of the vertex? Because the axis of symmetry, I already know the X value. So can I figure out the X value of the vertex? Yeah, it's right here. For this problem, it's right there. It's 1. So if you find the axis of symmetry, you're halfway to finding the vertex. The X value of the vertex is the axis of symmetry. So if you find the axis of symmetry, we just found it for that problem, it was 1. I'm halfway to finding my vertex. I'm halfway to finding the turning point. This is Molly.
No. This is
Yep. Bye. Evan needs to finish a math test.
You're done.
English, maybe? So, what you need to do is substitute the axis of symmetry, which remember is an x equals something, right? Into each x value in the equation. To find the y value. You can find the axis of symmetry. And then once you find the axis of symmetry, you use that value, because it's an x equals value, and you put it into each x value in the equation to find your y value. So let's do that. We had the equation y equals what? We put it in standard form, didn't we? 3x squared minus 6x plus 10. Is that right? And my axis of symmetry was x equals 1. So I'm going to put y equals 3. And then for every x, I'm going to put 1, because that was my axis of symmetry. So this equals what? 1 squared is 1 times 3 is 3. Negative 6 times 1 is minus 6 plus 10, right? 3 minus 6 is negative 3. Plus 10 is positive 7. So what's my vertex? What's my ordered pair vertex. 1, 7. I'm going to graph this down here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Uh-oh, I screwed up. My axis of symmetry was at 1, correct? Is that true? My axis is like that's where I'm going to fold. So I'm not folding right in the middle. I'm folding right here. And then my vertex is 1, 7. So 1, 2, 3, 4, 5, 6, 7, right there.
There's the point even.
That's where it's going to turn. It's going to change directions. Ladies and gentlemen, does this parabola open up or does this parabola open down?
Up and down.
Down. It opens up.
Oh.
Why does it open up?
Because positive.
A is positive. It's going to go like this.
Don't.
Does it have a maximum or does it have a minimum?
Minimum.
So once you've done this, we're going to make it a little bit easier to graph because yesterday our parabolas didn't really look very parabola-y sometimes, right?
Parabolish.
So what you can do now is pick the x value 1 space away from the axis of symmetry to substitute. So my axis of symmetry was what? It says pick the x value 1 space away from the axis of symmetry to substitute. What was my axis of symmetry?
1, 7.
My axis of symmetry was 1. So what x value is 1 space away?
0.
0 or
2.
2. Does it matter which one you pick?
Meeny, meeny, miny, mo.
0 or 2. In this problem, it's 0 or it's 2. Which one do you want to substitute?
0.
Yeah, 0 is easier, right?
Yeah.
3 times 0 squared minus 6 times 0 plus 10. That's 0, correct? That's 0, correct? So what does y equal?
2.
Plot this point. So my ordered pair was 0, 10. 0, that's 7, 8, 9, 10. And ladies and gentlemen, I plot this point. There's an axis of symmetry. What does symmetry mean?
It's the same on both sides. So
It's the
like
same
on
on-
2, it'll be the same as 10.
So I'm going to plot this point
What's that?
and reflect. Because if it's 1 space on the left side, it's going to be 1 space on the right side. and you repeat step 1 with I'm gonna go across this, so it's gonna be hard to read. The x value 2 spaces away. So this tells us, this makes our life easier. We don't have to pick random numbers like we did yesterday. We can now make our parabola look more parabola-y.
Parabola.
So I can either pick what are 2 spaces away from my axis of symmetry. What could I pick? What are my 2 options?
-1 and 3.
-1, or I could pick 3. I like to do positive numbers instead of negative numbers just because it makes it a little bit prettier. We're going to run out of room on this graph, but then I have a more parabola-looking parabola.